Hello! Today, I invite you on a fascinating journey tracing the passage of time from the shadow of the sun to the vibration of atoms. This is a journey that begins with the natural world, the movement of the sun, the dripping of water, the flow of sand, and extends into the mechanical ingenuity of gears, eventually reaching the precision of atomic oscillations. Measuring time is not merely a technical task. It is one of humanity's oldest questions, reflecting both our curiosity about nature and our desire to understand ourselves. The journey of measuring time, from sundials to atomic clocks. Time, we hear it, we experience it, yet we cannot touch it. We may feel that we have captured a moment, only to realize that it has already passed. This ever-flowing, elusive force is something humanity has sought to define, measure, and comprehend for millennia. Philosophers, scientists, and everyday people alike have grappled with this concept. Time manifests differently depending on who observes it. For a child, it is the long-awaited birthday. For a scientist, it is an experiment confined to split seconds. For a lover, it is a night that refuses to end. For a soldier, it is a decision made in the blink of an eye. Time is at once measured, felt, and often beyond understanding. Time is the common thread through all change in the universe. Planets rotate, seasons shift, hearts beat, all beneath its shadow. But the crucial question remains: does time exist independently of our perception, or is it merely a construct of the human mind? From Plato, who described time as the reflection of change, to Aristotle, who defined it as the measurement between before and after, and finally to Einstein, who framed time as a fabric intertwined with space, bending according to motion and perspective. The concept of time has evolved through thought and observation. Regardless of definition, human nature has always sought to know, measure, and control time. Without understanding time, life would remain uncontrolled. Humanity did not simply live with time, it attempted to capture it. And this quest began with shadows. The celestial calendar. When shadows became clocks, humanity first looked to the sky to find time. The heavens followed a regular pattern. The sun rose and set, the moon waxed and waned, and the stars shifted their positions with the changing seasons. This celestial rhythm inspired a fundamental question: could this order be measured? The earliest method of measuring time was surprisingly simple. It was a shadow. As the sun moved across the sky, shadows lengthened and shortened, naturally marking the hours of the day. This was the birth of the sundial. In ancient civilizations such as Egypt, Babylon, and China, a simple upright stick, known as a gnomon, cast a shadow upon the ground. The direction of the shadow indicated the hour, while its length revealed the season. In Egypt, massive obelisks were erected in temple courtyards, monumental structures that doubled as celestial calendars, predicting both the hour of the day and the progress of the seasons. Sundials were impressive, effective, and inherently tied to nature. Yet they were not without limitations. They could only measure daytime. Nighttime rendered them useless. Clouds could obscure the sun and erase their shadows entirely. On overcast days, time itself seemed to vanish. Yet, for early humans, sundials represented the first triumph over the intangible nature of time. To measure the sun was to grasp the rhythm of the universe. And understanding this rhythm did not mean conquering nature. It meant learning to live in harmony with it. But humanity's curiosity did not stop with the heavens. One day, attention shifted from the sky to the earth. People began to search for time in water, in sand, and eventually in gears and mechanisms. Sand and water, turning flow into measure. When the sun disappeared and shadows fell silent, time itself did not stop. Humanity still needed to understand its passage. The question arose, how can we know time without the sun? The answer lay in movement, flowing substances that could mark intervals. Water and sand became the earliest tools to capture the invisible current of time. Water clocks, or clepsydras, appeared in Mesopotamia, Egypt, and Greece. These devices measured time through the regulated flow of water from one vessel to another. As a container filled or emptied, the passing duration became tangible, quantifiable, and repeatable. They timed rulers' speeches, judicial proceedings, and religious rituals. Water, transparent and impartial, flowed at a constant pace, offering a fair measure for all. Yet water demanded careful observation. Its flow could be altered by heat, humidity, and the angle of the vessel. The need for a more stable measure led to the invention of the hourglass. Hourglasses, consisting of two glass bulbs connected by a narrow neck, allowed sand to fall at equal intervals, transforming an invisible flow into a visible and tactile representation of time. Each grain was a single moment. Each descent, a memory. Hourglasses became especially valuable in maritime navigation and domestic life. They measured work shifts on ships, cooking times, and even regulated speeches. They provided the first visual representation of holding time in human hands. However, neither water nor sand could stop time. Both continued to flow, both eventually emptied, and both returned to silence. Humanity's next step was to seek permanence and precision, to make time not only seen, but controlled, fixed, and reliable. This quest for certainty would ultimately lead to the use of mechanical gears, paving the way for a new era. The mechanical revolution. Time in gears. After first observing time through shadows and then tracking it through flowing water and sand, humanity sought a more precise, controllable method. People wanted to divide, stop, and measure time with certainty. This desire gave birth to the mechanical revolution. In medieval Europe, growing cities required structured schedules. Monasteries needed accurate times for prayers. Towns required coordination for markets and public events. And civic life demanded organization. mechanical clocks emerged to meet this need. The earliest examples were monumental mechanisms, often installed on monastery walls or cathedral towers, powered by large gears. These clocks did more than tell hours. They symbolized order. Time, once considered divine and intangible, became a human-made mechanism under human control. Though early designs lacked pendulums or springs and were far from precise by modern standards, they marked a revolutionary shift. Time could now be measured mechanically. Each tick of a gear or rotation of a wheel represented a step, a moment, a change. Clock bells rang across city squares, not only announcing the hour, but setting the rhythm of society. Citizens began to coordinate activities around these audible signals. Time transformed from a natural flow into a collective agreement shared across a community. The mechanical revolution also marked a shift in perception. Time was no longer only something to see. It could be heard. And as the technology matured, the presence of time extended beyond towers. Soon, it would become a personal experience, moving from public squares into the pockets of individuals. Mechanical clocks were a testament to human ingenuity. They signaled the birth of a new era, in which humans attempted to dominate, structure, and synchronize the invisible flow of time. Time in the pocket. The personalization of hours. Medieval tower clocks made time a public affair, shared by all who lived under the same spire. But as cities grew and societies became more complex, individuals demanded control over their own hours. Time became personal. Pocket watches emerged in the 16th century, initially as luxury items for European aristocrats. These small, ornate devices were more than tools. They were symbols of status, wealth, and taste. Carrying a pocket watch meant holding one's time in one's hand, rather than relying on public signals. With personal timekeeping came profound changes in daily life. Appointments, journeys, and meetings no longer depended on the sun's position. They followed exact hours. Punctuality became a virtue, a sign of reliability and discipline. The way people organized their day shifted dramatically, and schedules could now be coordinated with precision. By the 20th century, wristwatches spread widely, first popular among women and later adopted by soldiers during World War I. A glance at the wrist replaced checking a pocket watch, saving precious seconds and allowing synchronization in critical moments. The wristwatch became a standard tool, merging function with identity. Time in the pocket transformed human behavior. Individuals began to race against it, structuring their lives according to its constant ticking. Each watch represented not just minutes, but a personal rhythm. The brand, style, and design of a watch reflected a person's lifestyle, preferences, and worldview. Time, once universal and shared, now moved with the individual. It was portable, personal, and deeply intertwined with human identity. This shift laid the groundwork for modern life, where the measurement of time is inseparable from its experience. Industry and time. The Age of Discipline. Once, humanity measured time by observing the sky. Sunrises, sunsets, and shadows dictated the day. With the Industrial Revolution in the 18th century, time became more than perception. It became an obligation. Factories, trains, and machines imposed strict schedules that demanded precision and discipline. The natural rhythm of life gave way to the rhythm of industry. Workdays were no longer defined by sunlight, but by the factory bell. Time equaled productivity. Efficiency became a moral and economic imperative. Machines worked with exact precision, and humans were expected to match their pace. A minute lost could result in significant economic loss. To maintain order, workers received pocket watches, and railway timetables were synchronized across regions. The need for coordination revealed a problem. Each city kept its own solar time, which created confusion for transportation and communication. The solution was revolutionary: time zones. Suddenly, the world lived in different hours simultaneously, yet within a standardized system. Humanity itself became measured. Being efficient, punctual, and disciplined was no longer optional. It was necessary for survival and success. Time transformed into charts, schedules, and data points, becoming an integral part of life's management. People were no longer merely experiencing time, they were optimizing it. Yet this control came with a philosophical question. Were humans mastering time, or was time beginning to master them? The Industrial Age revealed that measuring and regulating time could shape society as profoundly as it measured minutes and hours. The pulse of science. From pendulum to quantum. Throughout history, humanity sought ever more precise ways to measure time. Mechanical clocks, though revolutionary, were not entirely accurate. Their gears, weights, and escapements provided a framework, but external factors, temperature, humidity, and even gravity, could affect their consistency. In 1656, the Dutch physicist Christian Huygens revolutionized timekeeping by inventing the first pendulum clock. Using the regular motion of a swinging pendulum, he was able to achieve a consistent beat that allowed time to be measured with unprecedented accuracy. The pendulum became a symbol of scientific precision and ingenuity, turning time into something tangible, predictable, and dependable. However, pendulum clocks had limitations. Altitude, temperature variations, and even small mechanical imperfections could alter their swing. Scientists and engineers continued to refine timekeeping methods, searching for even greater precision. By the 20th century, quartz crystal technology emerged as a solution. Quartz crystals vibrate at a consistent frequency when an electrical current is applied. This predictable oscillation provided a new standard for accuracy in timekeeping, forming the basis of electronic watches. Quartz watches brought second-level precision into the daily lives of ordinary people, not just scientists. Yet even quartz was not the ultimate frontier. The pursuit of perfect timing led humanity to look inward, into the atom itself. By observing atomic vibrations, scientists could measure time at scales previously unimaginable. The pulse of science had shifted from mechanical swings to atomic rhythms, promising a level of precision that surpassed centuries of human innovation. Time was no longer merely measured. It became a quantifiable, universal phenomenon, bridging observation, technology, and the fundamental laws of nature. The atomic age, racing with milliseconds. The journey of measuring time, which began with shadows and flowing water, reached its most precise stage with the discovery of atomic vibrations. Humanity sought the ultimate accuracy, turning its attention to the microscopic world. Atomic clocks operate based on the vibrations of cesium-133 atoms. These atoms resonate at a highly stable frequency when stimulated by microwaves. This resonance is so reliable that the very definition of a second is now tied to it. Today, 1 second equals exactly 9,192,631,770 oscillations of a cesium-133 atom. The implications of this precision are enormous. Atomic clocks are not merely tools for telling time. They underpin satellite navigation systems, synchronize global communications, enable advanced physics experiments, and guide space exploration. GPS systems, for example, rely entirely on their accuracy. A 1-second error in an orbiting satellite could translate into kilometers of positional deviation on Earth. Modern atomic clocks are astonishingly precise, deviating by less than a billionth of a second per year. Humanity now possesses the most exact measurement of time in history. Time has transcended human perception and entered the realm of universal truth. Yet, even at this level of precision, a philosophical question remains. While we can measure time to nearly absolute certainty, how well do we truly understand it? Precision alone does not guarantee comprehension. Time may be measurable, but its meaning continues to elude human intuition. Atomic clocks demonstrate that time can be tracked with extraordinary detail. Yet life itself may not exist in the millisecond. Perhaps the essence of living lies not in fractions of seconds, but in the singular moments that shape experience. Measuring time or capturing it? Throughout history, humanity has sought to understand and master time. We observed shadows, measured water flow, counted grains of sand, engineered gears, utilized quartz crystals, and finally reached the atomic scale. Yet the question remains, what have we truly gained from all this progress? Yes, we can measure time with incredible precision. Atomic clocks can track milliseconds, and our schedules are meticulously organized. Pocket watches, wristwatches, and calendars have made us punctual, but at what cost? We have gained control, yet spontaneity often slips away. Moments pass while we are focused on the next appointment or deadline. measuring time does not necessarily mean living it fully. We accelerate life's pace, but do we truly enrich our experience? The essence of time may lie not in counting seconds, but in feeling, experiencing, and understanding each fleeting moment. Like the shadow cast by a sundial, life leaves traces behind. Yet while watching that shadow, we may miss the sun itself. Atomic clocks measure minuscule fractions of a second, but life is contained not in milliseconds. It exists in singular, profound instants. These instants shape our relationship with time, revealing that to seek time is, in essence, to seek ourselves. Time is not merely gears, numbers, or instruments. Time is lived experience. It is human perception, memory, and consciousness. The deeper we reflect, the more meaning time acquires. Today, we have traced humanity's quest to understand time, from the shadow of the sun to the vibrations of atoms. This journey reminds us that time is not only a measurable concept, but also a lived experience. By measuring time, we attempt to understand our own existence. Every clock, every watch, and every second reminds us not only of minutes passing, but of life itself. Perhaps in the future, our perception of time will be entirely different. Yet one thing remains certain. As long as humanity exists, the pursuit to measure, understand, and relate to time will continue.